Information to cover today, all about the intro to special projects. So if you happen to not be enrolled in 256B, that's a surprise, but yeah, all of you are, I think. If not, you can still get yourself enrolled. We can take care of that. But so what we'll do today is kind of run through some of the nuts and bolts of what to do, what to expect over the next week and a half, and then what to expect over the rest of the semester as well. So a lot of things that we need to accomplish in the next week. So we'll touch on those as we go here. So the quick. To get things started, everybody, I assume, already has picked up one of the yellow syllabi on here. Okay, if not, I've got a couple extras up here, so come on down and grab one. Just a couple of quick little highlights going through that. This is pretty much things that you already should know, and if you don't know, that's a big surprise. But ultimately, you should know when your lab section is meeting and stuff like that, who your lab prof is. Those things hopefully haven't changed, or if they did change, that you know exactly why and where you're going. If you're interested, there are some dates on the second page. I will hit those in some more detail as we go specifically. So you can check those out. Everyone is always interested in grading, of course, so the breakdown in grading on this. Ultimately, in this half of the semester, what the grading will consist of is that initial proposal that you will do, and then a final report that you will do, and then what you do when you're in the lab. And that's really about it. Okay. And I would say, I'd probably speak for my fellow lab instructors, that if you're in the lab often and putting good effort into it, it doesn't matter if you make your products or not. It's the effort that you put into it far more than what the product that comes out. So anyway, that's the details there. And we got the normal kind of things about if you have disability issues, let us know. Although there isn't much in terms of exams and things in this portion. And then academic integrity, don't cheat, don't lie, don't steal, and we'll all be good. So anyway, that's the very, very, very quick rundown of the syllabus. So take a look through there. It can be helpful to have some of the due dates and things that are there. But otherwise, let me know if you have any issues there. I think that's pretty straightforward. So, all right, other things to note. Okay, so just breaking down what to expect over the coming weeks. We'll put it into some chunks, and I'll go into some detail. Okay, so when you should be looking at the background, your project definition. What are you going to make? That's what you should be doing right now. Okay, we'll go through where exactly the details on that here coming forward, but that's what you should be doing right now. Other important things in your timeline, you should be preparing your proposal. That's going to be due next week. Okay, next week, Tuesday or Thursday is when that is due. Okay, so be sure you note that. We'll note that several more times today. Okay. After that, so when you come back from spring break, we will dive right into your carrying out your proposed work. Okay, I'll give you, again, a little bit more detail on what we're going to do there. Okay, but you can plan on that as soon as you come back. Get rolling and start those projects up. Note that by the last week in April, so April 25th, I think, is the Monday of the last week of classes. Okay, that's about the last point where we'll be doing the finishing touches on any experiments. At that point, it's going to be cleaning things up. Wrapping things up, and then ultimately you will write a final report, and that's going to be due the last Friday of classes is what that April 29th is. Okay, so your specific lab instructors may tweak those a little bit in terms of the timing, but these are pretty similar throughout. Okay, and so that's generally what you can look ahead to is kind of figuring things out this week, preparing that proposal, and then after spring break we'll be just doing chemistry. Okay, you'll be happy to know that this is the only lab lecture section for the second half, so you'll now have your Monday afternoons free to do your special projects. Okay? Or on days like today, you can probably take a little bit of a break. But anyway, that's just a heads up in terms of the schedule. All right, so we'll kind of go through these in a little bit of detail. So right now, you are hopefully all in the process of devising that three-step synthesis to a target of your choice. Okay? Hopefully, you've got a target in mind, and you're kind of in the process of looking for background literature. Okay, if not, that should be way up on your to-do list for this week. Okay, what I think I speak for all the lab profs when I say that we make it a very interactive process. If you have a couple of ideas and you're not 100% sure, bounce those ideas off your lab prof. Go back and forth often. Don't be afraid to kind of ask. Okay, this is what I'm thinking. Does that sound okay? The last thing we want is for you to put in hours and hours and hours of lit searching to end up with this beautiful route to something that we won't let you make through a process that we won't let you do. Okay? So lots of interaction back and forth. We're going to help you out with those things. Yeah, we want you to try that that you're using your time constructively and using our time constructively as well. Okay? If you don't already have a route in mind, it can be target driven if there's a molecule that you want to make. Or it can be a reaction-driven, and you really want to run a Wittig reaction or something like that, and you can kind of compose a synthesis around that. That's fine. Just in terms of taking numbers, how many people have a product structure in mind already? So most of you, there's a few who don't. Okay, so those of you who didn't raise your hand, now that peer pressure, you're feeling a little uncomfortable, it's a great thing to do soon. Okay, if you come up with something on your own, that's great. And if not, all of the lab profs have different molecules that we have, kind of stocked away that could be great synthetic targets. Okay, so get on that sooner rather than later. Okay, if you are doing research at all for within the chemistry department, in the bio department, even in some cases psychology, if they're looking for a small organic molecule or just an organic molecule of some sort, ask them. Okay, so we make some unusual compounds sometimes that aren't just pure organic research driven. So yeah, ask around, see if anybody has something that they would like made, and we'll see what we can do. All right. It's very important, the literature precedent. So once you've got that target, that you have literature steps to get there. We don't just kind of randomly take chemicals off the shelves and say, oh, I think this should work when we put them together, right? And pour them together and see what happens. We try to avoid that whenever possible. Okay? So all three of your steps must have a literature precedent. And I'll talk a little bit later about how similar they have to be, right? It doesn't have to be the exact same reaction by any means. Okay, but if you're converting a carboxylic acid into an ester, you better have a precedent somewhere that shows how somebody took some carboxylic acid and turned it into an ester. The closer those molecules are, the better off you are. Okay, sometimes you have to kind of go far afield and make some educated guesses. Sometimes you can find the exact starting materials and products. Okay, the closer they are, the better, but you have to have a precedent for each step. Okay. All right. What you will find, those of you who have already done some looking into the literature, a clear experimental section is a big plus on those literature precedents. Okay, some of them will lay out experimental sections that look like they are straight out of a lab manual, that they will tell you absolutely everything. Others will tell you they took A and they took B and they got C out. And that's all that they say, and you have no idea what the workup is or what the concentrations are or anything else. Okay, so the more detail you can get, the better. All right. Hopefully in your experience in the library section, you've seen how to get articles up, how to look at supporting information. Okay, that often will have those experimental sections in detail there. Sometimes they're in the body of that work, in the article itself. Okay, everything's a little bit different, but hopefully you've got some experience there and you're at least getting into the first steps of figuring those out. Okay, as with other aspects, if you have questions on those, touch with your lab profs, come talk to me. We can figure those things out. All right. And that's, again, be interactive with the professor. Get your professor's approval on what you're doing before you go too far. Again, you don't want to spend hours and hours along some path that we aren't going to let you do. Okay? All right, any questions so far in terms of kind of identifying your target and your route? All right. Okay, and if you don't have that target, that's the thing to do, ASAP. Okay, the sooner the better. Typically this week in lab, the general game plan will be to hone that route to the target so you know what you're going to make, what's the best route to get there, and starting to do some of those calculations on how much materials you're going to need at each step, things like that. Okay, that's what we really want to do this week. We don't want to spend this week in the lab just kind of looking at random targets and trying to decide. Okay, hopefully you're kind of getting things down to sort of which route you're going to take this week in lab, so then by next week we can have that proposal. All right, so the proposal, okay, you now have a molecule, you've got a good idea of the route that you're going to take. Now what do you do? All right, so I don't know how many of you have those handouts with you. Okay, if you happen to, you may want to grab it. So I'm not going to talk about this salmon-colored one. Okay, so if you don't have it, the great news is, and for those of you watching at home, okay, it's all on the Moodle site. Okay, so note that we are going to be using the 256B Moodle site for this one, so it is different from the previous lab lectures. All of these, the electronic versions of all of these are available on there. So if you don't have the salmon sheet, you can take a look at it. I'm not going to go through this in gory detail. It has gory detail about pretty much every step. Okay, what I'm going to focus on right now is what does that proposal need to look like next week? Okay, so you're going to, that proposal we've said is due next week. What do you need? What goes into that? What do you need to do? What do you need to know? Okay, we'll go through that right now. All right, so the proposal format, it's laid out in pretty good detail. You look at page 6, for those of you who have it in front of you. Okay, it's laid out in pretty good detail. I'm going to work through each of these, give you some more detail. You'll note that my numbers are slightly off from the numbers that are here in this checklist, but that's a pretty good idea of what you're going to need for that proposal. Okay, So you have this one with you. I'm going to have this, of course, online as well. All right, so of course you need to put your name on your proposal. Whether or not you're proud of it, you got to put your name on it. Okay? All right, you got to put your date, your lab section on there so we know who you are, what you're doing. All right, and of course, what's the goal of the project? So the first thing beyond that kind of requisite information is what's the goal? What are you making? You know, what's special about the route that you're going to make it through, if there is something special? Why are you making it, and what's it good for? You know, what's the purpose of doing it? And if you're going to make the compound that smells like strawberries, and the reason you're going to make it is you have always dreamed about, you think about strawberries in your sleep, and you want to just make that compound, that's fine. Put that in your goal. That's kind of odd, but that's okay. We don't judge, okay? But you just want, what's your rationale for doing it? What's special about the route that you're going to take, okay? All right, so that's what you want to do in the goal of the project. Again, short little paragraph, couple of sentences, what you're making, why you're making it. Okay? All right, then what you're going to have is 3 proposed reactions. You're going to have your synthetic route to making your molecule, your target molecule. Okay? You want a brief description, okay, of, or for each step, whichever one you want to do that. Okay? How it relates to you want a precedent, so you want what that reaction is, okay, what the precedent is, okay, and any notable aspects of the procedures. And that's a little vague, right? I know that little thing is vague. And that's why I have the next slide, so don't copy too much here. Okay? One reminder to all of you, all of these PowerPoints, of course, are up on the Moodle site, so you can go back and correct all of my mistakes for me when you take a look at it. All right, so this is what your step is going to basically look like. Okay, so this is step 1. Okay, I pulled this off of someone's proposal from several years ago. So here's the general idea. Okay, you've got step 1, it's clearly labeled. You see the reaction scheme for step 1. Okay, typically with each step, you're going to have a little paragraph there that describes what's happening in that step. Okay, you may want to talk to your lab prof for sure of what they want in there. Some want a pretty detailed procedure. Others want just sort of a broad overview of what's happening in that step. Okay, so just check for sure. Okay, so ultimately in this one, we say that we've got the 2 reagents are going to react together. One tip for the word for the wise: if you spell out the name of a reagent once and put its assign it a number in parentheses like that, then you can use that number for the rest of the proposal. Okay, so it's a nice little way to avoid writing those horrible names down more than you have to. Okay, so the diethyl tartrate in this case, and then the dimethoxypropane are going to react in the presence of a toluene sulfonic acid catalyst, okay, and then form this product. Okay, so that doesn't tell you a whole lot. It gives you a little bit there about what the reagents are, what the catalyst is. Here's really the key. It's nearly identical to the literature precedent. Okay, and note that I cited that literature precedent there, but it'll use toluene instead of benzene because benzene is hazardous. Okay, and so that's this is an example of a literature precedent that is essentially exactly the same. Okay. So there I've got the reaction. Down here, you might want to, again, touch base with your lab prof to say how they want to use endnotes or footnotes. Okay, so you can look up those, talk to them about the gory details. Some of them will simply want this listed under the reaction. Okay? Others will want that as a footnote or an endnote at the bottom of the page at the end of the reaction, either way. Okay? But regardless of how you do that, you want to have that literature citation there so we can look that up and make sure that things look good. Okay? And so in this case, there's the reaction I propose doing. Okay? You want, often, I would suggest putting a little blurb underneath it, literature precedent. Okay? In this case, it's the identical reaction, okay, but with a benzene solvent is what the literature precedent is. And then the yield of that reaction is 89%. Okay? So that's a case where essentially the literature precedent is exactly the same as the reaction I'm using. Okay? So anybody have any questions on how we set this up? In terms of the step, what's going on in there, the reaction scheme? Any additional comments? No? Sounds good? Okay. The peanut gallery doesn't chime in unless we're doing okay. All right. Okay. Let's try step 2. Okay, yeah, there he said, consult with your lab professor. Some might want the full written procedure with values calculated. Typically, I for one ask for those a little bit later on, or kind of separate those a little bit. You may want to, double check. Okay. Well, that's what Johnson told us to do. Might not go over well all the time. So be sure, again, just be, in consultation with the lab rep. Okay, step 2. So now I have one where I varied it a little bit. Okay, so here again, we're taking this diester from step 1, and note that I just called it diester 3. Okay, because I've got that letter or the number there, I don't have to write out the horrible name of this compound. Okay, it'll be reacting with a Grignard reaction or Grignard. with a Grignard reagent in a Grignard reaction, okay, with the methyl magnesium bromide to form this product here. And so there I note that it's very similar to the literature precedent, okay, which instead used a different Grignard. Okay, and so here you'll note again I cited a couple of different things. I recited number 1, which I didn't put down here, and then this is now a second reference. Okay, so both of those literature citations are there. And what might be worth considering as well is this step requires an inert atmosphere, something that's a little bit special about that step if there's something in there. Okay, and then following workup, it'll be purified using column chromatography. So you have a little bit in there about what the reaction is, anything special in that reaction, the fact that it requires an inert atmosphere, okay, and that it gets cleaned up with a column. Okay, and so now here is my proposed reaction, and now in this case for my literature precedent, I'm going to go ahead, it's different, and again it's not hugely different, but it's slightly different. It's enough that I'm going to go ahead and draw what that literature precedent is. Okay, so note that in this case I'm using the phenyl magnesium bromide instead, and I make a slightly different compound, and the literature yield for that compound 78%. Okay, so when there is a difference, you know, you make a different product or something like that, you probably want to draw out your proposed reaction and the literature precedent. Okay? In this case, this is pretty minor. You can imagine something being significantly different, that this works on benzoic acid, but the literature precedent has a whole lot of spinach on the side or something. So you know, draw those out whenever whenever they're not exactly the same.
Should we do all this on like ChemDraw or something? Or?
Yes, I'll talk about ChemDraw later. Yeah. Okay. There's already some of you who are envious of the nice structures that I've got up here. I'll show you exactly what my secret is. Okay, so you too can draw structures like that and impress your friends. Okay, any other questions? Any other comments back there?
So like you could mention anhydrous pH up there, right? That would be, those are the kind of other things that would be like those procedural detail things that we probably would want to see, right?
Yeah.
Inert atmosphere, anhydrous solvents.
Yeah, so if there's anything special that goes into there, we'll see later on there'll be a place to kind of put special equipment and things. But yeah, if there's something special about this reaction, if it's not just take your two chemicals and pour them together and let them go, it's great to kind of put into that little introductory paragraph of what's going on. Okay? If there's temperatures, in this case it's room temperature, then reflux, those are pretty straightforward. But if it's a minus 78 or something, an ice bath, okay, it's worth noting in that little paragraph. Okay, and so this you'll do this with all three. I'm not going to show you a third step, but that's the general idea. If you got an exact replicate of a precedent, it's pretty straightforward. Okay, slight changes like this, you can go ahead and put both reaction schemes in there. Okay. All right. So step 4 then. Okay, so that's step 3, and if you look at this sheet, I think it's labeled as 3 and 4 of the reaction sequence in the literature precedent. Okay, so this is my numbers start getting off here a little bit, but it's the same content. Is any special equipment? Okay, so any unfamiliar equipment and conditions you probably want to put in this section right here. Okay, so once you've got those 3 things, what else do we need to find for you? Okay, so it's equipment that you can't find in your lab drawer is really kind of what this means. Okay, and so it could be like an inert atmosphere. We'll hook you up with a bubbler and some things that will allow you to do that. Okay, if you need giant equipment, 4-liter Erlenmeyer or a set funnel, something like that. Okay, you can put that in there, something that you don't have in your drawer. Okay, so we can find those for you in the lab. Other things you can't really see it. Here's a vacuum distillation setup over here. Okay, column chromatography. You'll learn in a hurry. It's not exactly like we did it in the Wittig experiment. Okay, and so we have that glassware, but it's nice to have a heads up that you're going to need it. Okay, other things you might run across, a Kugelrohr distillation, or a Dewar flask. These are relative, well, I wouldn't say the Kugelrohr is common, but Dewar flasks are pretty common. Let us know what you need. Long story short, if you're looking through that experimental and you're like, I don't know what that is, let us know and we'll help you figure out what it is, and if we have it, then the chances are pretty good that we can find it somewhere here in the department. So, but it's just nice to know that before you're setting up the reaction. Long story short. Okay, so any questions on that in terms of special equipment? All right. Okay. All right. So now we get into table of the reagents. Okay. So now we've got we've listed the proposed reactions and everything, just like you've done before. Okay. You want to do a table of reagents. Okay. It's pretty much all the same things that you saw before. Here's feel free to grab a copy of this off of the PowerPoint. You can use this as your template. Okay. Compound. One additional thing I'll note here is the chemical abstract, the CAS number. Okay, each chemical that's out there that's known essentially has its own independent number. Okay, so it's very useful to record that as well. I'll show you where to find it here in just a second. Okay, and then kind of the standard information here. Okay, and then finally down here in the end is hazards. Okay, and I'll talk about that a little bit more in a second. Okay, so some examples. So step one, these are the examples of different reagents that are necessary for step one. Okay, you have these are the cast numbers that are there, all this information. One thing to keep in mind is do use what's relevant. Don't feel like you have to go find out what the melting point of sodium bicarb is or something. You don't have to go crazy to find you have NaCl. What is the melting point, right? But use what is useful in there or what is relevant to your reaction. And then ultimately I'll get back to the hazards down here in the end is good to know. Okay, so you'll put step one and put everything down, everything you're going to need there. Then put step two, a little bit of a break in your table. Then list all the chemicals that are going to be required for step two. Okay, then do step three. Okay, so it's essentially you want all of that information up front in your proposal. Okay. Now the key. Sigma Aldrich is a great site to look these up. So far when you've been filling out data tables, where have you looked this stuff up? So for all the experiments so far. Okay, CRC. Okay, so you've done, some of them just Google it and see what pops up, and Wikipedia, whatever. Okay, what I would say is Sigma Aldrich is a great site, and it's going to help you in a number of ways, and I'll show you that going forward. What's useful here is you want both this data, but then also the hazards. One thing I'd just like to kind of emphasize is so far, all the chemicals that we use so far, we know what they are, we know what we're willing to use in the labs and expose everyone to, so we know what all the the hazards are for these. Okay, we don't know what you're doing exactly. Okay, and so you might be using some chemical that we're not familiar with. We want to know if there's something there that's gonna make you grow a second head, right? You're trying to avoid the use of those things. So that's what we do is we look that up and find those for you. Okay, and so I'll show you here in just a second how to do that. Let's see if I can flip here without too much of a problem. Okay. So Sigma Aldrich is really probably the best place to look for these. All right, let me see if I can do this. I was going to bring a mouse along and I forgot. Okay, Sigma Aldrich. Okay, so on the Sigma Aldrich site. Okay, how many of you have visited the Sigma Aldrich site sometime in the process of looking up things? Okay, so most of you have been here before. Okay, so you can simply look up different compounds. I will try, let's see. Hydrofuran. Okay, so for the most part, you can just look those up. Okay, so here's an example. There we go, tetrahydrofuran. Okay, and so I want to get this information from it. So what I will do is go ahead and grab one of these and pop them open and kind of see if I can get that information out of this. And so, let's see. At this point, I'm just going to pull this top one. We'll talk about which ones to pick out in terms of purchasing and stuff a little bit later. All right, so you get that information right up there on the top. There's that CAS number. It's great to write down because that's unique for every single compound. Okay, you've also got the molecular weight that's easy right there. The physical properties are just a little bit of a scroll down right there, so you can get all those basics. Note that little show more button. Drop that down, and you'll get the boiling point and the melting point and all that sort of jazz. All right. So what's the interesting part here is if you look at safety and documentation. So that tab right there. Hit on that, that'll slide you down right here. The safety information. Okay, it's got these really scary looking symbols on it, so that means there must be something about this chemical that you should be aware of before you just pull it off the shelf and use it. Okay, it turns out that there are several different ways to look at this and several different meanings for these. Okay, so these are the pictograms that are the ones that you'll often see on the bottle, so they each mean something, that there's some health hazard here, and then ultimately a flammability issue. Personally, I don't know that my colleagues in the back might tell you something a little bit different. What I like to do is look at this hazard statements right here. These tend to be pretty specific. Okay? And what I will do is if you pop that open, it opens up a second window. Okay, and then it gives you this hazards and precautionary statement kind of window here. If you scroll down, it'll tell you what all these things mean. Okay, so that flame there, okay, so that you see as the hazard, it'll tell you that there's some flame concern. These are all the possibilities that might be an issue. Okay, although those are typically flammable compounds. Okay, if you go down a little farther, you see the one with the exclamation point. There's some sort of acute toxicity or irritation issue. Okay, but that's kind of a wide range of stuff, right? There's a lot of different things that could be. Likewise, the health hazard. You know, there's a lot of different things in there. So you know that there's something you should probably take a look at. Okay, so what I like to do to be most specific is if you go up here into the hazard statements, okay, so that's this set right here. We've got those numbers. If you look at that little thing, the hazard statement, the overview, what it'll do is it'll pop up a PDF. All right, and you can't see that, but ultimately these are every single one of those like little codes, and it will tell you what it is. Okay, so you can see what the code is right down here, and so you can take a look and see what that little hazard statement is. Okay, so if you look in there, you can see that it's, you know, an extremely flammable or a highly flammable liquid and vapor. So I can tell you that pretty much every solvent that you're going to run across is going to be highly flammable. Okay, so you can look up each of these different codes. Okay, it's a flammable solid, or it's a, you know, heating may cause an explosion. So each of those little H numbers will tell you what the specific hazard is. Okay, so if I flip back to that other one, I hope that this will happen. There we go. And if I look, okay, so I'll look at this other one. So that was H225 is the flammable liquid. If I look at, say, let's try H335. If I look at that PDF again, okay, what did I say, 335, so I'll look at there on the second page. Okay, so 335, H335 may cause respiratory irritation. Okay, so if you stick your nose in there and inhale, the THF will probably hurt. Okay, but ultimately these are the things to take a look at, though, just to know what they are. A lot of them are really pretty mild. Some of them are concerns. Okay, and unless you look these things up, you're not going to know for sure. One thing I will tell you is a lot of them seem very, like, you know, scary when you look at them. Some of them are things that you really do need to be careful of. Some are really pretty innocuous. And so it's a great thing that if you do have concerns about these, talk with your lab profs. Okay, you'll talk about ways to properly handle them, and some of them might be nasty enough that we're not going to deal with at all. Okay, so anyway, take a look at those up front. Usually we will take, you know, if I look through a procedure, a proposed procedure, and I have a pretty good idea of that's going to be a bad one, so we should avoid it, or this will be okay. Okay, be sure you check those things before before you go too far. So do you have any questions about looking up these chemicals on Aldrich and then finding the like the hazards and looking through those?
Should we record the H codes or just say flammable?
That's kind of up to you. If you're worried about them, go ahead and write them down.
Just like a specific.
Yeah, in the table, it's fine if you just put what the fact that it's flammable. Okay, or it may cause, you know, inhalation irritation, so it's fine. Yeah. But yeah, if you do want to check on one of them, yeah, it's great to have the chemical name and then what the code is, and then we can kind of help you out. All right, any other questions?
You put words in the table, right? I don't want a table that just says H237, because like you, I don't know what that means.
Yeah, right. So yeah, when we go back to the, let's see, where's the, there we go. When you go back to the table, note like on the side there, it's flammable, irritating to eyes, is suspected carcinogen. Yeah, that's what we want in the table. But if you want more information, you know, bring that code along and we can look it up and kind of chat about it. Okay. All right, any questions in with this table of reagents? You're going to do this with all your compounds. Okay. Some will be more innocuous than others. Okay. Some will be pretty interesting. All right, and like I said, it's very useful to write down that CAS number because that's going to help you in the future here, moving forward. All right. Okay, now that's kind of similar to that the physical data table there, but yet distinct. Okay, so keep this in mind. Is we're going to have a chemical order form. Ultimately, we need to make sure that we either have all of the chemicals that you need for your synthesis, or we can get them by the time you're ready to use them. Okay, and so in order to do that, I need you to fill out a chemical order form. Okay, some things to think about. We need to look, do we have them here on hand or not? Okay, one place to look, you got this purple sheet. Okay, you see the purple sheet? So standard solvents, some of the basic solutions, either acids, bases, the 1 mole or HCl, stuff like that, we have in the stockroom. Okay, you want to put it on your physical data sheet, but you don't need to put it on your chemical order form because it's on this purple sheet. Okay, so if you see it on the purple sheet, you don't need to put it on your order form. Okay, so that's one thing to check out. Okay, if it's not on this purple sheet, it has to go in your chemical order form spreadsheet. Okay, how to find out if we have it in the department? Okay, it's via that link right there. Okay, so the MSDS online. I can get it to open. All right. Okay, so we can look up the MSDS online. All right. Okay, so note that the login and the password there were on that page. I'll go back to it in a second. And so you can log in. Okay, and you get this set up right here. So it's got a whole bunch of stuff down there. If you want to check it out, feel free. Ultimately, what we generally use this for is, do we have this chemical in the chemistry department or not? Is what we want to know. All right, and so what I am going to do is I'm going to search up there in this box right here. Note that I can search by CAS number. That's where that CAS number comes very handy once again. Otherwise, you can also type in the name and see if we have it. Okay, so what I will do here, okay, type that in. Okay, we'll search for toluene. All right, we'll see if it comes up. One thing that can also be helpful when you do this is to see up here in this box right here is select location. That gives you an idea of where all the chemicals are and if you specifically want to find it in one place or another. Okay, so if you do it in the chemistry department, okay, that makes life a little bit easier sometimes, so you don't have to go and knock on somebody's door in the art department and see if you can borrow their, turpentine or whatever. Okay, and so now you get this list of different things that came up under toluene. So now what I'm going to do is scroll down there and see if I can find toluene. All right, so here we have toluene. Okay, so I will click on that. Okay, a whole bunch of information. What we're really interested for is down there on the bottom. Okay, so the inventory. Okay, 3120. So there's some of that chemical, what I'm looking for, in room 3120. Okay, so you want to take note of that and write it down. Okay, of course, something like toluene is probably on the purple sheet. You wouldn't have had to do this anyway. Okay, but for your other chemicals, we want to know, is it present in the department or not, and can we go find it? Okay. Ultimately, what's going to happen is next Friday, after I have all of your proposals, me and a couple of very, very helpful peers of yours, who are probably juniors and seniors, are going to go on one big wild goose chase and try and find all of the chemicals that you guys say are in this department. Okay? Yeah, that's right. When you're off on the beaches or whatever, think of us poor schmucks that are sitting back here looking for them. Okay? Ultimately, this is going to help us at least know where they were last seen. So the last known whereabouts of toluene, right, was 3120. Okay, toluene, of course, is all over, but there are going to be some chemicals like this that are specifically in Professor Gilmer's lab or specifically in my lab, and that at least gives us a place to start looking for those things. Okay, so you're going to have to do this with each chemical, okay, that is not on that purple sheet. You're going to have to look it up on the inventory sheet, look down here under inventory, and see if you can find it. Okay, does that make sense? Some of them are going to be easier than others to do that with. This is a great thing to try out this week in lab, whether you're in lab on Tuesday and Thursday. Try it with a chemical or two, pull up this system, search for it, see if you can find it, okay, and just make sure you kind of know how the system works. It's a little bit more precise if you have very specific chemical names. All right, any questions on using this to find the chemicals in the inventory? All right. All right, back there. All right, so like I said, it's kind of easiest to search by CAS number. That can be very useful. If you get that CAS number first, you can just punch in the CAS number, and then it's very, very specific. Okay, and if it's present, note the location. Note that it might not be present. Okay, that's also very, very good to know. All right, and for all chemicals, even if they are present, you have to find a commercial source. Okay, first place to look for all those is Sigma Aldrich. If Sigma Aldrich has it, be sure you write down the name, write down that catalog number from Sigma Aldrich. That's the one that we're going to kind of have as the go-to. If you can't find it, you probably want to talk with your lab prof. There's several other chemical companies that we will occasionally order things from. Okay, but you better really mean it. Okay, and so your lab prof will kind of help you figure that out. Okay, and so you want to do that for every single chemical on your list, even if it's present. Because I hate to tell you this, but that inventory, while it's not bad, sometimes I used up the last part of whatever chemical it is, and I toss the bottle away, but it's still in the inventory. Okay, there's some time between the time that we empty it to the time that it gets listed. Okay, it might be gone, and we might have to order it anyway. And I don't want to look all those things up for you. Okay, so you get to look them up. So be sure you put them on that list. All right. Okay, here's the key. Use the provided Excel spreadsheet. I will show you what that spreadsheet looks like on the next page. I'm also going to send it to you via email, and it's located on the Moodle site. Okay, so you're going to have lots of ways to get a hold of it. Okay, Solvents and solutions on that purple sheet can be omitted, but all other chemicals must be on that list. Okay, if you want to intend to use it over the next 6 weeks, it has got to be on that list. Okay, otherwise there's no guarantee that we're going to get it. All right, what does that sheet actually look like after me talking through it like that? Okay, you put each one down here, put your CAS number here, the amount needed. Okay, that's really important. As you go through and kind of estimate where, how big your reactions are going to be. Okay, so it makes a big difference whether you need 1 gram or if you need 10 grams. Okay, so we need to know how much to have on hand. Okay, and we will figure that out if necessary. Okay, and if appropriate, tell us where that is, the location. Amount on hand with our current system, I don't think we can figure out how to get that. We used to be able to figure out how big the bottle was at least. Our current system doesn't do that for us. So you just need to know what the location is. So in that last example, I said there was some in 3011 or whatever that room number was, 3010. Okay, be sure you write that room number down under location. Okay. If we do not have it on campus, let me know the quantity to order. Okay, which is probably the same as the amount needed. Okay. But that helps me then if I can combine them if more than one people need the same thing. Okay, the supplier, pretty straightforward. The catalog number, so the Aldrich catalog number. Be sure you write that down. Then put your name in here on every single line because ultimately it's all going to be mushed together into one giant ordering spreadsheet. So you want to put that in there. Then what your prof's name is, and then what step that you need it for. If it's your first step, your second step, your third step, and so on. Okay. Ultimately, you each will fill this out in an Excel spreadsheet. All of you will email it to me. I will combine it into one enormous spreadsheet, figure out what we have, what we don't have, go on that wild goose chase I talked about, and anything that we can't find, we will order. All right? Any questions with that process of getting all those down? Any additions back there?
Actually, minor questions too. So for quantity to order, you want how much they actually need, not the fact that the smallest bottle is 100 mils.
Yeah, I think how much they need is probably.
And then for prof's name, that's whose lab section they're in, not whose, if they're doing a Stanford project in Foo's lab, you want Foo's name.
Yes, your lab prof. Yes, thank you for that clarification. Okay, because then that helps us just decide which chemical is for which person and how to keep track of all of these things. Okay? It's one big organizational mess, so we're just going to hope that everybody gets what they need by the end of the day. All right, any other questions? All right, good. Okay, again, little hints and tips that I'm going to emphasize. Supplier and catalog number provided for every compound, even if it's here in the department. One note for the future: when I combine them into that one Uber list, I'm ultimately going to say, inventory every chemical that we have out. We will pull them from the shelves and put them into like hoods and stuff for you, so they're easier to find. We will put them all in alphabetical order. Okay, just a quick note: things like numbers in front of a name, or an R or a trans or an orthometapara, things like that, are not included in that alphabetization. So when you come back from spring break, you're looking for the chemicals that you need. Don't be surprised if there's no section of 2s or of 3s or something. Okay, it'll be alphabetical by, typically it's by the first letter, unless it's one of these special designations. So we can help you find that out if it comes to that. But just ultimately, when you're looking for those chemicals at the other side of break, that can help you out. All right.
One other one that comes up on Gilmore projects a lot. The chemical name should be what Aldrich calls it, not necessarily what your procedure calls it, right? Your procedure may tell you to use methyl iodide, but Aldrich might sell iodomethane.
Good point, good point. So it does help if you put the catalog, whatever Aldrich has as their main name. Aldrich is pretty good that if you search for iodomethane or methyl iodide, it will pop up the same record, but do put the Aldrich name down because typically that's what you're gonna find on the bottom. Although not all the time, it's a mess. Okay, but usually Aldrich's name in their website will match what's on their bottom. Okay, so that's a good note. All right. Okay, other final proposal items. Okay, so you have this giant sheet. Okay, well you'll hand that in. Okay, other things to include: photocopies of your lit sources. Okay, I typically would suggest that you want to actually put the lit sources in there rather than just saying what it is, whatever. You want the actual lit sources in your proposal. What I usually say is do the front page of the article and then whatever pages have the actual procedure in them. Okay? Your prof might want the full article. You can touch base with them for sure. But as long as you have that front page of the article so it's easy to find it again if necessary, and then you have whatever page actually has the experimental. Some of these can have supporting information that are 100 pages long. Don't you dare print that out. Okay? Just print out what you actually need, a page or two. All right? Yeah, that's right. We don't have a stapler that big to handle a whole read. All right. Okay, so you need to include that in there. All right, a PowerPoint slide with your name, your section, and your target molecule. I will give you a template for this, but you need to turn that in. So what you're going to need on there, I will give you a template for that. It's available on the Moodle site. You want your name on there, whatever section you're in, the molecule you're making, a quick little thing about why you're making it, and then a picture. Okay? Here's, I was going to look for a really exciting picture, but yeah, I put my kids in there instead. All right? So you can put whatever, kids, it's not exciting at all. All right, so go ahead and put whatever picture you want in there. Let us know it's you. And then ultimately what we do with this, we do two things. Okay? We put this, we'll print out like essentially a one-page version of this, and we put it over your hood where you're working, so we know who's working in which hood and what they're making. That helps us as we're just kind of scoping out what's going on where. The other thing is I will take all of these slides, combine them into one poster, and we'll hang it up outside of the organic lab. Just as people are going by, we can see what all the students are making and things like that. Okay? So we will ask for that one-page PowerPoint slide printed out and attached in the rest of your proposal, okay, with everything else as well. I'll also ask for the electronic copy here. So hopefully that's pretty straightforward. All right, and that's it. So the recap, here's everything that you need to put in that proposal. Okay, one giant stapler, put it all together. Ultimately, you want to hand in 2 hard copies. Okay, so it's due next week, Tuesday, next week, Thursday. Okay, 2 hard copies. What we do with those 2 hard copies is we basically will grade one and then return it to you. The other copy we will keep. So as you're going through all of your stuff, we have a copy and we know what you're doing during the lab section. Okay? So 2 hard copies for that. Also, you want email number 6 and 8. So that ordering table and the PowerPoint slide, I need electronic copies of each of those. Works a lot better than me copying everything away. Okay, so I want electronic copies of those so I can do all the ordering and get these, get that big poster put together and everything else. All right, any questions on all those items from the proposal? That's a lot of stuff.
So we don't need to print out 6 and 8?
You print it out and include it in there as well. So it's both. Both put it in the hard copy and send the electronic copy to me. Okay. I'll admire all the rest of your proposal at a different time, but I just want those 2 pieces at the moment, so, or next week. All right. Okay, good.
Let me throw out there, CC your lab prof on that email to Professor Johnson. Then we know that you got it done, and we're not having to run down and say, well, did so-and-so get this in yet?
That's a good idea. Otherwise, I go down the hallway and I gripe to Gilmore about his lazy students. Just don't get things in on time. So yeah, he doesn't want that either. So, all right. Okay, one note that I have to emphasize, if your complete materials are not received from me, I would say Friday at 8 a.m. I need to get going on getting all of these things together, finding all these things, getting them ordered and everything else, okay? That's the absolute, and if I don't have it by that time, you're done, okay? So if I don't have the, the chemicals to look for, that's really the rate limiting process, step in this process. If I don't have that stuff by Friday morning, that's the absolute last ditch for me. You may already be in trouble with your lab profs who expected it on Tuesday or Thursday. But if I don't have it by Friday morning, then that's it. Okay? So we're going to say thanks but no thanks and boot you out. Okay? Because I need that to get rolling. So anyway, we'll remind you, it won't be any problem. But in case there's some electronic catastrophe and you have to deliver it just by hand or something, whatever. But that's really the absolute ending. Okay? Questions on that?
That's next.
And that is, next Friday. Yeah, after the 2 days. Yeah, surprise, that'll be the easiest special project for us ever. Nobody's seen it. So, all right. Okay, a couple other things to just quick mention. After you return for spring break, which seems like so long from now, okay, at your earliest convenience, what you want to do is stop by the lab. I will have a list of all the chemicals that we have that everybody is doing and tell you at least a little bit about where to find them. You want to go through and make sure you can find them. Okay, so it's your earliest chance stuck into the organic lab for a while. Find all those chemicals. You want to leave them where they are. Okay, we'll probably have them laid out in hoods that aren't being used. Okay, you want to leave them where they are because there may be multiple people using the same chemical. Okay, but be sure that they're there. Okay, and if you can't find anything, be sure you come and find me or your lab prof or one of the TAs or something. All right. Some other just kind of general ideas. Before you perform an experiment, you have to have a written procedure to follow with the appropriate values. So that can, like in my case, I will take the lab like the literature precedent, this is the precedent I'm going to follow, but I'm going to use these values in terms of what amounts of reagents. That's fine, but you have to be following something. Okay? You can't just be winging it. That doesn't go over well. Okay, you have to have a pre-lab for each experiment. That's going to look pretty much like the pre-lab you've done before. Okay? And then you want to okay the timing with your lab prop. When are you going to start it? When are you going to work it up? What you'll find is not all of these reactions that you're going to do work in a 5-hour window. In fact, very, very few will work in a 5-hour window. Okay, there's lots of overnight refluxes or reactions that go for different amounts of time. So it's not unusual to come in, say if your lab is on a Tuesday, come in on Monday afternoon, set up the reaction, let it go 24 hours, and then work it up at 1 o'clock when your lab starts the next day. Okay, those are things to work out with your lab. Okay, so don't start any reaction without the okay. Is really the key there. And then while performing the experiment, these are things that you've done before, right? Okay, all the standard, record your experimental, things like that. Product analysis should all be in the notebook. And then you want to provide a mini conclusion for each step. Okay? So when you've done that reaction, when you've done the workup, all of that, you want to write it up. Okay, say, yep, I did what I wanted to, we're on to step 2, or nope, I didn't make any product at all. We're going to have to repeat step 1. Okay, again, this will become more clear with your lab prof as you go through. Okay? All right, and then ultimately there will be a final report. Okay, some might be a compilation of everything that that all of these mini reports, and just smash it all together and call it a final report. Other profs may ask for something a little bit more detail. I'm going to let them hash that out because you're not going to remember what I say now in 7 weeks anyway. Okay. All right, but by Friday, April 29th, what I do is I need a notebook. Well, actually, your lab prof needs your notebook, okay, including all the little bits. Turn any labeled samples of products that you've made at each step, okay? And then you want to check out a lab, okay, whatever, check out of your drawer. Those are all the things that are necessary by that end, okay? So keep that date in mind. It's a long time from now. Okay, I thought I would take like 2 seconds right now. We're getting kind of close, but I will show you ChemDraw really quickly. So the secret to drawing those really neat structures. Okay. All right, it's going to take just a second here. We're going to switch gears. All right. All right, so this computer here is just like any other computer that you're going to find in like any of the labs around, or in the computer labs or the dorms or in the science center or anywhere else. Okay. If you go under the main menu, the start menu, under all programs, you will find that chemistry link. Okay, and this is pretty much the same spot where you found TopSpin before. That's where you can also find ChemDraw. Okay, so you can use ChemDraw. All right, we let it gear up. All right, here we go. You can use this program. Here's all the little tools to do this. Those of you who use SciFinder will see that there are some distinct similarities between how this is set up in SciFinder. Okay, it is relatively intuitively obvious. One thing I personally, I don't know what my colleagues think, I really like the ACS style versus the default style. So if you go on File right away and hit Apply Settings, and just hit that ACS 1996, I just think it makes them all look nicer. I don't know why. I'm like, yeah, I have high standards for chemical structures. Okay, so I'm like a structure snob. All right, so if you go ahead and do that, then you can just draw here. You'll see that the tool here just makes a solid bond. You have some of your rings and things like that that are just templates. What I would suggest is just go ahead and kind of use this and play around a little bit. Okay, you can click and you can add bonds and you can draw bonds and you can put things in and double bonds and whatever else you want. It's pretty straightforward. If you want to start labeling atoms, okay, you can click on them and then write in whatever atom label you want. Okay, some other things that are available up here is arrows. Okay, you can pick any of these arrows. Okay, so if you want some standard reaction arrow, you can draw it. Use that text box and put whatever reagents you want in there. And call it LAH. Okay, whatever you want, you can go ahead and put that in there. So this is it. There aren't too much for, well, actually there are tons and tons of secrets with this program, but ultimately you can do the basics really pretty easily. Okay, so find that ChemDraw on the chemistry site there like this, and play with it a little bit. Use this to put it into your like a Word file. All you need to do is just highlight what you want to take, copy it, flip over to your Word file, and paste it right in, and it works like a charm most of the time. Okay, so especially on this older version, there are some little kinks that we run into now and then. let us know if you run into anything too bad. But that's really pretty straightforward to cut and paste that into the Word document. All right. Any questions on ChemDraw? All right. And so ultimately, we'll flip back to this other one. At this point, just to recap, this whole list of what you need to do and when you need to do it is available up online. The PowerPoint is up online, so I know there's a lot of stuff that I went through. Be sure you go back and look at that file, double check everything. Okay? There's a lot of stuff to know, but the lab process will help you. All this information is available for you. Anything else that you generally would like to add before everybody runs for the nice weather? Oh, you kids have to stay after class?